Okay, everybody, it's notes time. We are taking notes today on area and perimeter right here. So, to avoid the page number debacle, I'm not going to write it down this time, but this is either going to be page 3 or page 7 in your toolkit. You just have to flip and find the page that looks like this. Should be one of those two. They changed up the page numbers on me. Okay, again, review notes, but good stuff because we need to know it. First of all, perimeter. What is perimeter? It is the distance around the outside of any shape. Well, any polygon. Okay, so perimeter, very easy to find. The perimeter of the shape is the total length of the boundary points. That sounds confusing. We're going to just kind of write ourselves a little note over here that perimeter, okay, is equal to, and to find the perimeter, we add all outside edges, right? Add all the outside lines together, and that is the perimeter. Looking at this one right here. Oh, I don't think I can draw that skinny. Okay. Yeah, no, we're not going to be able to do that. Okay, if you're looking at a shape that is gridded like this, you're counting all of those outside lines, right? You can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, 20 around the outside. Anytime they give you the grid, you can just count them. But remember, count all the outside lines. If it is a shape that is not gridded, then you would look at the length, right? This is 3. This is 5. So 3 plus 5, but there's another side over here. 3 and another side 5. So 3 plus 5 is 8, and another 3 and 5 there is 8. So you could say 8 plus 8 is 16 would be the perimeter on that one. But we're not going to worry about that. Okay, perimeter is the easy peasy one. The other measure that we have to worry about is the area. And the area is the space. Oh, my writing is very sloppy today. Inside. Okay. And area is measured in square units. Units squared, that little 2 there. Because it's literally how many little squares fit inside that shape, right? So square units. In this case, the M stands for meters, so that would be square meters. Now, unlike perimeter, for any shape, add all the sides together on the outside, you got the perimeter. Done. Area, they each have their own formula, so it gets a little bit tricky. Okay, but we're going to highlight them. You have highlighters, bust them out. Okay, the area is the measure of the number of squares needed to cover a region of a flat surface. That's just a fancy way of saying on the inside. Okay, the area of the rectangle is the base times the height, and we're just going to write it here. Base times, remember the dot means multiply, height. Okay, for any rectangle. A square is a rectangle, so that counts too. Okay, rectangles are easy. And that here's the thing, most often I hear students go, oh, area, it's easy, you just multiply. Well, for rectangles, yes, but not all shapes are rectangles, right? So down here, we have a parallelogram. Okay, area of a parallelogram, it's a slightly different shape, right? It is also the base times the height, right? There it is, B times H. B stands for base, H for height. But if you look at this, the height is that line right there, right? It's on the inside of the shape. So it's a little bit trickier, right? On the rectangle, the base is the bottom and the height is the side. On the parallelogram, the height is on the inside because it's telling you how tall is that shape, right? So it looks like the same formula, but you find the number in a different place. All right, getting tricky. The area, oh, I didn't want to do that color. Trying to be organized. Highlight green. Okay, the area of the triangle. This one, they wrote the formula right here, right? I'm going to give you another way to write this. The area for a triangle, so instead of writing the word, I'm going to use the shape, is equal to the base times the height divided by 2. Okay, dividing by 2 is the same as multiplying by a half. So dividing that by 2 is sometimes easier than dealing with the fraction. Okay, so again, notice where the base and the height are. The base is here. The height is that straight up and down dotted line, which sometimes is on the inside of the triangle and sometimes is an outside edge. It depends on what kind of triangle it is. But the way that you're going to recognize it, and I don't think I can highlight skinny enough to make, oh, I can go smaller. Okay, look for that little square. And I shouldn't have highlighted that in green. I'm going to erase. Hopefully you're not working too far ahead of me there. Okay, if you look for this little square, that is going to tell you where the base and the height connect. That is an excellent little tool to help you make sure that you're using the right two numbers. Because if there were numbers over here, you wouldn't need those for the area of a triangle, right? Just the base and the height. Okay, last formula. This one's tricky. We're going to talk about this in class this week. The area of a trapezoid. Area of a trapezoid is a big old funky formula, right? You're like, what the heck does that mean? 1/2 times base 1 plus base 2 times the height. Okay, a lot of stuff going on there. Well, here's base 1, here's base 2, here's the height. Again, notice we have that little right angle square to help us realize where the base and the height are. Okay, well, just like with the other formula, I'm going to write this one here. Area of a trapezoid, and I'm going to abbreviate because you get to do that in notes, is equal to, one way we can do this, kind of like what we did with the triangle, is say, okay, base 1 plus base 2. It's just the bottom and the top. They're parallel. You're adding them together, so it really doesn't matter which one you do first. Base 1 plus base 2 times the height. That's that how tall is it line. All of that divided by 2. So that's just, it's the same formula. It's just another way to write that formula. I should maybe make a note here that fraction bar means divided by. Okay, just like up here, I use the fraction right there, right, to separate those. A fraction is just a division problem. So when we start doing a little bit of algebra, like we're starting to do, that represents division. Okay, I know we didn't do any examples here, but we're going to talk about some of these formulas in class and do a little practice there. So highlight and write your notes, and we will do the practice besides the notes, but then you'll look at them to kind of give you some guidance if you don't remember, which is what they're about.